Hey, hi guys. So in this video, we are going to discuss the LLD for the Splitwise application. Let's go through the features required. The first one is the user management. So we should add or remove the friends which we can normally do in the Splitwise application. Another one is the group management, creating the groups, adding the members or the users to a specific group, tracking the group expensive. The main component of the Splitwise service or the app is the expense management. We should be able to manage our expenses. We should be able to add the expensive, mentioning who were the participant or the member, where amongst which we need to split the expenses, whether it is equal division or the unequal division, and the balances, and again the settlement part basically. So if we go through this one, let's figure it out. The basic entity which we are looking here is the one is the definitely the user. The another one is the group. The another thing is the you can say split type, the expensive, the balances, the final reminder. These are the basic entities which we are looking. Now let's go through the design patterns. So what we are going to use here is the singleton pattern. We are using singleton pattern for the user management here to figure it out how many. So we'll be having a single class which will be having all the informations about all the users, basically how many users we are having, and all the user related informations or the operations will be handled by that single class. Now another one is the factory pattern. We are using the factory pattern here to create the types of the expenses, whether it is equal, unequal, or percentage. So whenever you are going to add any expenses, it will have a specific type that, hey, do you want to divide the expense equally amongst everyone, or do you want to divide it unequally, or are you assigning some percentages? So to create the objects during the runtime, we will be using the factory pattern for that purpose. Observer pattern is again just to notify the user about the changes. So whenever, let's say, you are adding the expenses, when you are including some members into that expenses, those members will be notified automatically through the observer pattern that, hey, you have been added to to this expense, and you have to pay this much, or you owe that much to that person, or the vice versa. The next thing is the strategy pattern. We are using the strategy pattern to for splitting the expensive. Like, what would be, we can have multiple strategies, like, hey, we want to divide the amount equally to all of them, or unequally, or maybe whenever you are saying unequally, you will mention either the ratios or the portions, or maybe the percentage would be a better way to mention it. So we are going to use the strategy pattern. We will go through the code later on. Command pattern is more, we will be using it for the expense related operations. What do, sorry, not the expense, yes, I mean different expense operation. What does it mean? For example, whenever you are paying or closing out the amount which you owe to someone, there are multiple operations which may require to that. So everything will be bind to a particular command that, hey, clear the settlement. Let's say this is the command which is getting triggered. Now it will have multiple operations, so that entire thing will be handled by the command pattern here, where you are bundling the data and a bunch of operations, tying it to a specific command basically. So for you, for as a code person, the main class, whenever they will calling the command, for them it will be abstract, like what is actually getting done. For them it's more about clearing the settlement or adding the payment, adding the expense, and all those things. The Facade pattern is used here to basically simplify the interaction, provide a unified interface to the system. I mean, I feel you can even ignore this one, but we'll go through how we are actually using it in the code. So if you see this diagram, we have this user class, we have this unequal expense factory, which is definitely implementing the expense factory interface, and we have this observer pattern which I have already discussed. Now this is what the all these are the classes. This is shows how they are interacting with each other. Now we'll start going through the code. Let me open the IDE here. So we should be having an IDE here. Just give me a second and let me open the ID, and then we'll go through it. So this is our entire code. Let's see the UML diagram which we are having for this. So if we go through this one, this is the entire UML diagram which you guys can go through. Let me zoom it out more. So here if we see, if we go at the top, we have a one class called user, a simple class, nothing like such. So another one is the expense factory. This is the factory pattern which where we are ending those two classes. Then this is the observer pattern. Then yeah, this is the command pattern which we are using here. we have defined a interface called expense command, then we have add expense, and we can have another kind of command also, like clearing the settlement, removing the expense. Sometimes, for example, our expense was added by a mistake, or maybe it needs to be removed later on for any amount of purpose, then definitely we need the remove expense command, so that can be also added here. It has an association with the expense. So association means basically it is we are using the expense class somehow inside this add expense command. We'll go through it in the code how actually that is really done. Let's go through the code finally now. Let's start with the command pattern only, since that is something which is so here we have defined this class called interface named as expense command, and we have an execute function. Now let's see what we are doing in the add expense. In the add expense, sorry, what we have done here is we are calling the execute function, and we are calling this class called expense, where we are calculating these shares basically. Why? Because when we are saying add expense is not just about adding the value to the person who is adding the expense. It's also about figuring it out how much one owe to the other person, or vice versa basically. So for that you need to calculate the shares for each of the member which is a part of that expense, which is getting initialized at a part of this one. Now let's go to the expense class. Yeah, if we see the expense class, this is the expense class which we are having, bottom class and abstract class. Here we have total amount. Okay, the total amount, the each expense is a kind of considered as a one entry or a row which is done by you as a user, saying that hey, this is the amount I have paid, this needs to be split among all these members. Now the participant are all the members and the users among which that split needs to be done. Share is the strategy basically, kind of how it needs to be splitted amongst the person, like A owns this much, B owns this much, C owns this much, D owns this much, and that's it. And the split strategy is mentioning like about what is the strategy which we have used there for splitting the expenses. Now this is the calculate share. Now let's see, now this expense is extended by equal expense class, unequal expense class, and maybe I think that's the thing. And let's go to the equal expense first. Okay, here we have something called calculate share. So here whenever you are initializing this equal expense class, you are passing the amount, participant, and new split strategy. Okay, so what is now actually here happening is this strategy is now passed to this expense class which is getting stored here. Now when you finally call this calculate share function, you say split strategy which you have initialized at the time of the class initialization, and you call something called split expense. You pass the total amount and you pass the participant. Since this is a equal expense, we don't need to pass any extra parameter, because this needs to be equally splitted amongst all the users, so we are fine with it. Okay, now let's go through this split strategy once. Okay, now let's go to this strategy pattern here which we are having is the equal split strategy. First go to the strategy pattern. This is the strategy pattern which we are using, as we have already discussed that we are having multiple types of strategy to split the amount. It can be equal, unequal, ratios, or whatever. This is the interface which we have written here. Now let's go to the equal one which we are actually using. This function is getting called split expense. Okay, share is passed, then the users are passed. Since this is the equal one, we are just equally splitting the shares among all of them and returning it. So when we call that strategy here, we are getting that amount from this one, and which is coming back to this one. Okay, so this is how the split is done. Now the shares have been logged into the system. Yeah, you can say hey, it's why we are not logged it anywhere, or maybe update the database. That you can add as an extra entry, but the purpose is to just show you how you need to write the code in the LLD and how the structure needs to be done. This is the one thing. Now another thing, what if this expense dot calculate share, which is this one, expense dot calculate share, the split strategy is an equals expense. So you will still call the dot calculate share. You are still calling the you are still calling the calculate share here whenever you are adding the expense. Now let's say the expense is unequal expense. Okay, if you go to this unequal expense, you will see you are calling the split strategy again same way. You are passing this one and you are calling it total amount and participant. But the strategy is what? Unequal split strategy. Now what is happening in unequal split strategy? You are passing the participants here. Okay, here for now we have not written the exact code how the splitting needs to be done, but what you will have to do is you will have to pass the share for each of the users. The way is to, you can say, hey, you can easily pass the something like this, maybe let's say double. Okay, I'm just telling you how it can be implemented, and you can say ratio, something like that, or percentage, whatever you want to call it, and then you can just write a simple for loop to assign those shares to those users. That is how the code is actually written. This is the major piece of the code. We have another class like observer user, but this is like heavily used. Now let's see the UML diagram once again, so you get the more clarity. This we have now gone through the code already. Okay, let's ignore this for now. We had this expense command, then we had this add expense. Add expense was calling the expense class. It was actually used inside that command. That expense class is extended by three two only. Equal, this is the equal, this is the unequal, and this is the equal. Now association means this expense class is used in the split strategy, and split strategy is a part of, is again extended by the equal split strategy and unequal split strategy. So that is how the entire structure look like. It may feel to you that hey, they are very heavily coupled, but they are actually not. If tomorrow a new split strategy comes up, you can always add it. Tomorrow you have new command, you can always add it to be at the parent level. If you have tomorrow another kind of expense, and you will add expense also, and then you will add the split strategy also for the same. So that's how the code can be really extended and following all the LLD principles. Now let's go through the other classes which we are having. As we have discussed in the initial, we will be using the singleton pattern for the user management. So as you can see, we are already using it. Whenever you are adding the user, whenever there is one thing which you may say, hey, group is not implemented, but that you can do. But the major part of this entire design was to focus on how the expense will be managed. You can add another class for the group manager, or you can even make it as a part of this also. That is fine. Now the another class which we have is the user, the basic class. Nothing much to be discussed here. Expense factor is just for use for the initialization of the expense, whether it's an equal expense, unequal expense, or like whatever it is. Observer pattern is the one which we are using to notify the users whenever a new expense is getting added. Now what will happen here is, again, we have not implemented it heavily into the code, but what will happen is you will register the observers to the, you will register all the participants to the this class, and whenever any update comes up, you will notify all the users. So that can be done here. Split strategy we have already discussed. Command patterns we have already discussed here. Facade pattern is the one which I have already mentioned. So here facade pattern, the way facade pattern is working is, it's working as a, if we go to the code as we have mentioned here, so the code mentioned here is kind of the same. It just better structurized into that ID which you get access to if you are a paid member of our course actually. So the pattern is used to simplify the interaction and provide the unified interface of the system. So this is like a, you can say, parent class. So whenever if you want to interact with the Splitwise service, we will just go to call this facade pattern. We are using the facade pattern in that way. So hey, add the observers. I want initializing the system. Say whenever you will add the observers here, these are the observers which will be notified whenever any change. Adding the new users, so user manager is getting called. Adding the equal expense, so this is the entire thing. Notifying the observer, so here we have definitely we are using the observer pattern here. As we can see, this is the observer here. And what are the observers? Observers, if we go, is the expense observer. Okay, so if we go to the facade pattern here, whenever the or not whenever there any whenever we need to notify the user, this function is getting called, and all the observers are getting called basically. Now here it can be another kind of observers also, user observer, group observer, whosoever needs to be notified in any way, you register it as observer and then you attach it then you add it to the Facade pattern here in this list to make sure that they are getting updated with, because here we are running the for loop to update all of them. Expense class we have already gone through, equal expense we have already gone through, this one is also, this is the final demo class to show you how we are going to actually use it, use the entire this piece which we have really written. If we move on to the next thing, definitely this is, the code is good, but there are some concurrencies issue. Like if you are work like really in an interview, um this question can comes up that, hey, will your code work fine in the concurrency environment? Now in the current scenarios, concurrency have become one of the major part of the LLD interviews. The concurrencies are being asked heavily now, because it really matters now, how your code will be working in the multi-threading, like how the code will be performing in those tight situations when the machines are under pressure, and so we really need to go through the concurrency issue. Let's start with the first one, which is concurrency issue in the expense. So if multiple users, since multiple users can add the expense at the same time, which can lead to the race condition, because there is no locking mechanism. What does that mean is, whenever multiple users are adding the expense at the same point of time, what do we mean by multiple users? So if multiple users are not related to each other, then it will never have any problem. But if the users are same, let's say there are three users, let's say for example, let's say there are three users, A, B, these are the three users. Now A is also adding, something, okay, and now B is also adding something, and they are adding among each other, like all three are included, A, B and C. Now whenever we are adding the add expensive here, and we are like calculating the share, let's go through here. The chances are that when you are updating the user's value, you are not assigning the correct value to them because of a race condition. What will happen when the split expense will be? This is what we are doing. You are putting the shares to the users, which is here. What is the share here? Share is this one, user and the double. What if this strategy is called and the users are same basically? If the user is same, this can lead to the race condition. This is what it is actually saying. Multiple users can expense at the same point of time into the race conditions when updating the balancing. When we are finally updating the balances of the user, and two users are trying to add the balances point of time, then the chances are very very high that it will not work out because of the race condition. Like, hey, one is saying, hey, this is 2, and another one is saying, but this is 3, and they know they both are not in any kind of a synchronization. So in those case, definitely this code will not work. The fix of this we have already covered in our course. If you buy our course, you will see the solution of this one there. The next one is the inefficient expense splitting. So how we are currently splitting the expenses is iterating over all the participant every time, making it a ON of square in the worst case. What if the group is large? What if the group consists of 100,000? Most like it does not happen very heavily in the consumer consumer requirements, but let's say it's a large group like company or corporate type of systems. In that case, this can become an issue, because what we are doing is we are going through all the users to split the things. For example, here if you see, we are going through all the users. Is there any better way to do it? Currently we are like, for everything we are making it a big of n square in the worst case, because we need to split the expense to all the participant every time. For example, if all of them are adding the expenses in some way, then the way we are splitting the expenses is not going to work. The time complexity will be worst in with the n of big of n square. I have kind of explained it more, like how it is big of n square into our course, and the solution is also again covered. The lack of transaction rollback in case of failures, then definitely this is the one. If a split transactions fails a midway, some users may have incorrect balances, so rollback mechanism needs to be again. I think we have already discussed this one, kind of interact and kind of goes same with the first or second point, the scalability. The code is not scalable if the group if the we have large number of users, because we are heavily dependent on the serial or the linear operation, and it will slow down the frequency balance calculation. If the changes happening to the user balance final balances are very frequent, then it will slow down our system, and it will trigger the multiple notifications leading to the performance bottleneck. The solution is again covered in a no notification throttling in the observer pattern. Each expense update not leading to the, so sometimes what will happen is, let's say if the changes are happening very frequently, it will notify all the observers immediately. It can lead to the notification overload also, like spamming kind of. So we should make sure that we are not kind of spamming, and we are um, high frequency notification result in a, so we need to fix that also. We need to make sure that the notifications we are sending, we are very aware of it, like what we are doing, maybe dividing the notifications into a different type, what is a high priority, low priority, and based on that making sure that we are not spamming the user. It can lead to the bad experience. So all these things we have already covered in our course. So you can just go to our course, go to the dashboard here, and if you see, if you go at the LLD standard thing here, which is this one, here at the bottom you will see the Splitwise. So here you will see the solution for